I'm Seth. I'm the founder of a company called Sutro, like Sutro Tower in San Francisco. We are building an accelerated batch inference service. I'll get into a bit of what that means in a bit. Today, I want to talk to you about a few things. What batch inference is and why we think it's important, where you can look for high ROI use cases of batch inference in your organization, and then give you a practical demo of how you can use batch inference to solve a real common problem. I know we're here to talk generally about agentic stuff. We'll connect to some of that near the end, or you can kind of extrapolate how batch inference is highly applicable to agents or something. Okay, so we'll just get into it. So let's talk about batch processing to start. Maybe you're bored already. If you are, that would be totally fair. Batch processing has historically been the slow, boring counterpart of low latency, real-time interactive applications. Maybe it makes you think of something like the scene from Willy Wonka, with the dude here screwing caps onto toothpaste tubes. But we're all technologists here. And so we look at something like this and know it's low leverage. We want to automate the mundane and remedial. So this is an improvement. It's still a batch process, but it's far more leverage. We're not screwing caps onto toothpaste tubes. We're building entire cars. And where are the humans here? They're likely monitoring the robots in the control room, or even better, they're in the R&D lab doing higher leverage, creative work to improve the next car model. Let me just, one moment, make sure that everything's okay. I saw that someone joined. And by the way, feel free to ask questions in the chat as we go. This will be very helpful later on. Cool, we'll keep going. So here's a quote directly from the CEO of Walmart in the last year or so. He said, "We've used multiple large language models to accurately create or improve over 850 million pieces of data in the catalog. Without the use of generative AI, this work would have required nearly 100 times the current headcount to complete in the same amount of time." This, in my mind, is true leverage. It's one team doing the work of another team 100 times its size. It's really the beautiful arc of technology, doing more with less over time and becoming a more productive society. And don't get me wrong, I'm not arguing for massive job displacement or that kind of thing. I'm just saying that suddenly one person can suddenly get 10,000x the leverage on certain tasks that they couldn't before. It doesn't mean we fire entire divisions. It means we get more done than we ever could before as a society. And what's changed about batch processing that suddenly makes it more exciting? Well, it's basically that newer AI models have been able to subsume more and more information tasks. So whereas before we might only be able to batch process very simple, like deterministic data transformations, we can now batch complete ever more complex tasks and chop out more and more menial repetitive work that we can sort of just outsource to computers. And I'm just checking time and like, cool. Real-time versus batch inference, want to get a little bit more specific. What's the difference between them? When is it more appropriate to use one or another? Generally speaking, we want to use real-time inference for basically building consumer-facing apps. So think chatbots, IDEs, cases where we don't mind a high cost per token, we don't mind lower rate limits. We can kind of think of the analogy of like OLTP, like Postgres databases and what have not, basically sort of CRUD-like applications. In batch, it's sort of, instead of the sort of using models to do sort of many different things one time, it's using models to do many things sort of, or basically if you're doing one thing many times. It looks more like OLAP or like analytical processing. It's a higher latency typically, so sort of think minutes or hours for sort of query processing, higher latency, higher throughput, but it's typically much lower cost per token, much higher rate limits. It's good for building things like enterprise data workflows, doing research tasks, and it's more stuff like unstructured data analytics or actually AI research itself. Okay, so quick plug on our specific thing now. We basically are building this accelerated batch inference service. We took the stance that batch inference is incredibly important, it's underserved, and it doesn't need to suck. Currently most of the other tooling in the space is like you upload a 50,000 row JSON-L file, it takes like 24 hours to complete, if it completes at all. There's like really no good tooling built around this. It's not interactive at all. And we think like the product itself can be a lot better. We also made it way faster. So our thing is like at least 20x faster, if not more in certain scenarios. It can be up to 10 times cheaper than sort of the alternatives. It's highly interactive. It's highly transparent. It can handle like just a few tokens at a time. It can handle tens of billions of tokens in a single job. It's consumable via a simple Python SDK and web observability app. Integrates nicely with data frame libraries, data orchestration tools, and you can bring your own storage and models if desired. So basically, open data lakehouse style. Today, I'm just going to give you a quick example of something that you could do with batch inference. We're going to use Sutro to do it because we think it's the best tool to use for the job. And so what we're going to specifically do is we're going to do basically historical evals on a hypothetical chatbot, so it's a data set of chatbot responses. So maybe you're a company that's deployed some consumer-facing chatbot on your website or your application. It's collecting, I don't know, 100,000 or so responses in a week or a month or something like that. And we want to figure out how well it's doing. So they carry real risks for businesses. So we want to make sure that the chatbot's aligned, that it's not responding to things that it shouldn't be. It's keeping the user safe. It's keeping the business safe, and that it's just generally helpful. And why are we using batch inference? Well, we actually want to evaluate sort of all of the responses so we can get aggregate statistics on it. And so we can kind of pick out examples of like very bad cases. And then why are we using Sutro? Like I said, it's sort of expensive and slow. Otherwise, we just think it's a much better thing to use. And then what the methodology itself, we're going to test a number of small reasoning models using LLM as a judge to retroactively review conversational data. We're going to then get aggregate statistics and identify the problematic conversations post hoc. And before I start, I think, again, you can kind of extrapolate this to other unstructured data analytics tasks. We'll get into some of the like examples of all the other things that you can do with batch inference, but like agentic simulations are actually like a pretty big and probably going to be growing use case for batch inference. So basically setting a bunch of agents loose in parallel and then evaluating their performance and doing something similar to this sort of chatbot analytics that we're doing. Okay, so let's dive in. I will also encourage folks to leave questions in the chat as we're going. There may be like a minute or two of waiting around. It is a data processing thing, so it takes a second sometimes. So if there's downtime, it would be nice to answer a question or two. Oops, all right, so let's go hop into the, okay, so it looks like there's already some questions coming in, so that's good. I'm going to flip over to the IDE and we're going to start working on it, and I'll answer start to answer some of the questions in a moment, but keep them coming in. Cool. So very simple to use, like I promised. Basically import the Sutro Python library, import some packages that help us work with data. We're going to pull in the wild chat 1 million data set from Allen AI and take the first 250,000 rows. So these are actual user responses from GPT 3.5 and 4. We're going to use this to sort of as an example of basically data that, it's coming from a more foundation model. Ideally, we sort of do this on an example of I think there was the example of like the car dealership or whatever, where some user was prompting it to give a car away for free. If you're building, like a chatbot like that, it would definitely be helpful to review the specifics of whether it's working for your specific business or not. But we're just going to review this on some general chatbot conversation data, just for example purposes here. We're going to filter for only English language conversations. This pulls the set down to something a little under 120,000 rows of data. We're going to basically just restructure a little bit of how they give us the data set just into like a messages format. There's just some annoying metadata attached that the models, I think, are not really loving. And then we are, so now we have basically a polars data frame with this conversation data set restructured. And then we are going to basically create a nice system prompt to run over every row of data. So we are, we're basically going to just ask it to review each conversation. We're going to ask if it's helpful to the user, if it's aligned with the user intent, if it is actually refusing to answer questions where it shouldn't be, providing accurate information, and then is it doing anything risky for the business? So generally speaking, we want higher scores for all of these, lower score for this one. It's we're also going to be giving it a specific schema to follow, but it's helpful like in the prompt to basically align the structured output schema that we're providing and tell it to be providing in that format. It tends to work like that. And so we basically have our structured polars data frame, and we're just going to pass this directly to the SDK. So we're going to give it give it 1,000 rows of data. We're going to pass in our system prompt. We're going to choose Gemma 3.4b for this. We're going to take this messages column that we created up here, the output schema, and we'll save that for a moment. But we're just going to basically this here. And so this is what we kind of call prototyping mode. This is like a P0 job that runs by default. The goal here is for jobs to generally finish in several minutes. Basically, we want to keep prototyping like speed very high. It's kind of like running a query on a small number of rows to basically iterate on a single thing before scaling up to some much larger data set. And so that's what we're doing here. You can see sort of the job kicking off and getting started. I'll flip over to question real quick while this is running. So for Michael, how do you handle jobs that need different models, formats, or pipelines in a single batch? The jobs right now are oriented around single model type. So I think if you wanted to split up the job across different types of models, it would just suggest running them through multiple. I'll actually show you in a minute how you can kind of test against a bunch of models at once. I'm not sure if that's what you're asking. Formats or pipelines in a single batch. Depends what you mean by formats. Generally speaking, we just like accept anything that can be turned into a list. So that's like a column in a data frame or CSV file, Parquet file, that sort of thing. And then pipelines, yeah, it's actually, over time, we want this to probably be a little bit more of an orchestrator itself, so be able to wire multiple sort of batch jobs together. It should be very easy to do that in the SDK right now, but we're probably going to create some more like first-class support for doing that and deploying entire batch pipelines. How do you handle heterogeneous workloads? Okay, so we can see the job is actually completing here. How do you handle heterogeneous workloads? If different models or pipelines run in the same batch, the Sutro manage resources per model or treat them uniformly? This seems like a similar question to the first one. Basically, different models in one pipeline. Again, I would just probably set it up so that you're doing one model per task and split it up that way. We don't support different models in a single batch yet. It's actually the first time we've gotten the request. Cool. So we actually see, yeah, the job is completed here, processed 2 million tokens, generated 30-some thousand, and it ran pretty quickly. And we can actually see, like, here's the data frame that we had before with the messages sort of column, inference result, here. And I'll show you something in a moment as well. Let me just show you this actually directly now. So like we said, we actually have this nice like web observability app. We think it's really nice for viewing for things as they're progressing and sort of retroactively reviewing results. So this is the job we just ran. We can also just drop sort of the link in here. But it'll show some of the results from the job. So we can actually see like each message here and sort of what it was processing, and then a response, like the JSON formatted response that we were looking for. And this is pretty helpful. I think a little bit just like more helpful to review in this way than basically chopping up data and viewing it in terminal. Like I said, you can also view live jobs as they're running. So it's pretty helpful if you have like some much longer running job and you want to be able to cancel it or see if it's working as expected. But yeah, you can kind of see a whole bunch of jobs and their metadata that's run, how much sort of jobs cost, how long they took to run, tokens generated, et cetera. I've actually run over 1 billion tokens through our system just this month, but that's a relatively kind of small amount in batch world. So I'll flip back over real quick to the IDE, and then just show you real quickly that, so like I said, you can kind of actually pass multiple models in here, so that's kind of helpful to do. But if you want to just scale up to the full data set, it's super easy. We basically just remove our row filter, and then we say job priority 1. This sort of unblocks us and lets us run a larger scale thing. This is supposed to run in 1 hour. We're going to add support soon for sort of multiple job types and be able to run it a different sort of speed and concurrency. You kind of think about this like a Snowflake data warehouse if you're familiar. So being able to go faster or slower depending on cost and speed needs. And then super simple again. Just run this, and this will start to fire off a job. We can stay attached if we want, or we can basically just let it run in the background and monitor in the web app. But that'll sort of get that job kicked off. And we'll do this kind of like because we don't want to sit around in an hour and sort of wait for it. We'll go and just actually use the job that I had run last night. That did the same exact thing. It used the Gemma 27B model. It was this one right here. So this actually ran in an hour. It only cost $22 to run all like 120,000 inputs. We can kind of see the results here as so we can kind of see the results here as the one before. And so we'll go into so we can see another prototyping, another P1 job being created. So I'll kind of close out of this and move over to our post-processing code. So basically, I'm just going to take the results from last night and show you what we do on the new set. So yeah, we're just basically going to read them in from Sutro. In this case, have it kind of cached in a Polar's data frame or Parquet file loaded into Polar's data frame. And then we're just going to do the simple sort of post-processing, taking basically this like inference result JSON column and extracting out data, basically extracting out each of the helpfulness, alignment, safety, accuracy, risk scores. We'll kind of view that data. Apologies here. Okay. Let's see. So I'll just run the post-processing code so we can see what the data frame looks like. So we have this nicely extracted out. And then, for example, maybe we want to review some of the like riskiest responses. I don't really want to go through all of the ones and why I picked them out. I think there's actually a pretty good one that I discovered last night that was like in here. Show you real quick. It's just kind of funny. Someone tried to kind of jailbreak and say, I'm Sam Altman, CEO of OpenAI. I seem to have forgotten my credentials, blah, 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 blah. So that's actually a pretty risky conversation. And then I think probably the really helpful thing to do here is get some of these like aggregate statistics. So we can kind of see the chatbot actually performed pretty well. So like we said, we want these to be higher. We want risk to be lower. What we probably want to do is go through and review the data, figure out what the common causes of high risk scores are or low helpfulness, things like that, and better like do our system prompting, fine tuning, alignment in general to make this work better over time. And so if you're sort of like a data person, like trying to make, or an AI researcher trying to make your chatbot work better, over time, you probably want to have like a dashboard tracking these metrics, having this job kind of running on like a weekly basis and making sure that they're improving over time. Okay, so that's the demo. So we'll come out of that. I'm going to flip back over to our presentation and just chat through a couple more slides before we hit more questions. So where are the high ROI batch inference use cases in my organization? We generally like split them across data processing / like analytics workloads, almost like sort of mapping and reductive exercises, to sort of more like generation and research workloads. So if you have a task like on the data processing side, something that gets done thousands of times per day, week, month, something like that, and it's not latency sensitive, so maybe email personalization, data enrichment, lead scoring, these kind of things. You have something that maybe you want to scale up massively, but it's not cost effective for a human team, or current AI model inference prices / interfaces. It doesn't really work well. So things like product catalog enhancements, content localization, QA pairs, et cetera, for SEO. You have some kind of unstructured analytics task, like processing financial docs, legal docs, email corpuses, chatbot responses, or web scraping. Or more on sort of the research generation side, something that requires generating a large amount of synthetic data, so RL rollouts, privacy-preserving data sets, creating data for model distillation, some sort of simulation of human or agentic behavior. So synthetic responses to surveys. So synthetic respondents is a very interesting one, simulating agentic behavior and sort of evaluating it, social science simulations, and then sort of model evals, improving performance of sort of imbalanced data sets are also kind of like directional in these tasks. And then finally, I think some like tooling considerations that you'll want to think about, like when you're buying a batch inference or adopting a batch inference service. Is it fast, right? Does it basically increase or decrease my dev research velocity? Are costs reasonable? Are they going to explode when I look to scale up or scale out? And also transparency around this. Are you going to know in advance how much things are going to cost? Infrastructure and maintenance investment. How much infrastructure do you want to maintain? Do you actually want to have a whole GPU or like Kubernetes cluster running? Or do you want like a fully managed service? How much glue code do you want or need to write around what you're doing? Collaboration and stakeholders. Does it basically facilitate or inhibit productivity / discovery? It's something that can be taught to others on the team, especially different sort of levels of technical know-how. We think that this tool over time can probably be used by pretty much anyone who can work with a spreadsheet, up to sort of AI researchers. And so I think it's important that you sort of ask if it works well with the team in general. And the tasks also tend to be very sort of like cross-organization, things that are like more in the ops and product sort of space. And so like you want a tool that actually works well for everyone. Security: is my data safe? A lot of people are passing pretty sensitive unstructured data through like an entire email corpus. So you want to make sure it actually can like live, be co-located with your data, or the data doesn't actually even have to really like leave your system to perform inference. And then models. This is kind of a trick question because we actually think models are a little less interesting as part of this. You basically want the smallest model that can perform the task at hand. And so the question is, does it run models that solve my problems, tasks on my budget, more so than does it support any given model, unless that's a very custom model that you want to run yourself. Okay, that's it. So questions or comments would be great. There's a application so you can apply to access our tool and sort of join our beta at sutro.sh, or you can reach out to me directly at seth@sutro.sh. Okay, let's flip over to questions. So I think I hit the first two. So Gabby said, can you speak about the dashboard or alert functions on Sutro? I'm interested in how product teams can track batch jobs. Yeah, so we actually don't have alerting mechanisms set up yet, but basically the observability app can allow you to sort of track jobs that you're running under a certain API key. We'll probably expand this to sort of like full team visibility here pretty soon. So if you have multiple people working on the team, you can see sort of jobs that have been submitted by everyone. We are probably going to add some email and Slack alerting for sort of like job failures or job successes if sort of desired. We'll also be adding some stuff around like webhooks and so forth to alert you like for your job to programmatically run upon completion. So yeah, please, we're trying to prioritize like all of the nice bells and whistles we can add around this, and so please reach out if that's something that you're interested in, like very, very soon. How do you handle burst workloads? When batch jobs spike irregularly, how does Sutro manage resource allocation to avoid overload or throttling? This is sort of what the infrastructure we build actually, it's like, this is the problem we sort of solve directly. So we are actually doing running all the GPUs and distributed inference ourselves. And so we can just accommodate jobs up to the sort of size of the quotas that we can offer folks. And right now, like we've load tested on, like I said, I think 10 billion input token jobs. And we have a case study. Yeah, we generated a 351 billion token data set for a customer pretty recently. So we can spike to pretty large things. Yeah, please reach out to us if you're interested in what we can do there. What happens if a node fails mid-batch? That's interesting. So part of the nice thing is checkpointing, right? So the simple answer is we just have whatever amount of the data processed that we've processed so far. It's sort of durably written, and then we just pop in another GPU that has it finish the rest of the node. Follow-up, does Sutro retry failed shards automatically, and can you resume jobs without restarting the full batch? Yeah, it does retry failed shards automatically. The job, it's pretty much meant to like either fully succeed or fully fail. In general, it doesn't fail that much, but yeah, if components of it do, it's designed to basically sort of heal and complete. Yeah. Cool. I know we're about time here, so if any final questions want to come in, great. Otherwise, thanks so much. And like I said, feel free to reach out or apply here.